using the central limit theorem, we figured out how to ensure that our shapes are normal, more or less. So let's use that idea and now start thinking about what that's going to mean for probabilities. Because we already know how to find the probabilities under a normal distribution using the ideas that we learned in Chapter 7. So how is that going to be affected when we start talking about sample means versus individual values? So let's look at this example. We have SAT exams are normally distributed with a mean of 1,000 and a standard deviation of 200. Now remember, that's for individual people. So your give or take on an individual person's score is give or take 200 away from 1,000. So if a person scores 1,200, you're like, oh, no big deal. If a person scores 800, that's one standard deviation away. But now we're going to consider that for samples of size n equals 1, which would be an individual, and a sample of size n equals 4. So imagine 4 random people taking the test and you take their average, right? It's like the 4 dice get rolled, except these are really big dice, right? So you have 4 random people taking the test and you look at their x bar. So we're going to find the probability that x bar is less than 800 for both samples. And what does this imply? So I have here my curves. So we want to label them. One is for n equals 1 and one is for n equals 4. So let me label those. One second. There we go. So I have here this black curve is when n is equal to 1. And then the mean is 1,000. You can see that center line at 1,000. And you can see that the inflection point's about 200 away. So standard deviation is 200. And I can actually label it with the symbol sigma because this was for n equals 1. So that means that the standard error is the standard deviation. All right, so that's that curve. Now I want to look at it for this gray curve right here. Well, that's where n is equal to 4. But I'm going to have to figure out my standard error here. So the standard error is sigma over the square root of n, which let's think about what that would be. So if it's n equals 4, then it would be sigma over the square root of 4. And sigma was 200. So I take 200 and divide it by the square root of 4, and I would get 100. So this one has a standard error of 100, and it's standard error. It's not standard deviation. It's the standard deviation of the sampling distribution of sample means, i.e. the standard error. It's how far apart the sample means are expected to be from sample of size 4 to sample of size 4. And remember that that standard error is based on the fact that this was a sample of size 4. If you had a sample of size 8, this number would be smaller. The bigger your sample is, the smaller your standard error. All right, now let's find those probabilities. So when n is equal to 1, what happens? Let's see. There we go. All right, so when n is equal to 1, we want to find the area under a normal curve in order to find the probability. All right, and to find the area under normal curve, so the probability that, in this case it's x because it's a sample size of 1, is equal to normal CDF, F. Now from what to what? So normal CDF always goes from left to right. So you have to think about the left-hand edge and the right-hand edge. So the left-hand edge of what we're shading is negative 1E99. The right-hand edge of what we're shading is 800, then 1,000, and then the standard error, which was 100. The standard deviation, which was 200, because this is a sample size 200. There we go. So that's what we learned in Chapter 7, right? So it's normal CDF from left to right with the mean and then the standard deviation attached. So let me find that with the calculator. So go to distribution, then pick number 2, normal CDF, from negative 1E99 to 800, 1,000, and 200. Enter. And then you get 0.1587 or so. So let me type that in. Okay, so there's 0.1587. Now realize what this means. This is the chances that one student, n equals 1, scores less than 800 is 0.1587. So a pretty good chance. But now what about when n is equal to 4? Well, then we're not talking about a single student anymore. We're talking about the average of 4 students. And you want the average of 4 students to be less than 800. Well, it's the same idea. It's still normal CDF, negative 1, E99, 800, 1,000. But instead of 200 on that back end, we want 200 over the square root of 4 because 4 was our sample size. And grant you, it turns out to be 100 in this case, but I don't want you to get into a false sense that it will always work out so nicely, because generally it won't. So let me go back to my distribution, pick number 2, but instead of 200 for my sigma, I want 200 divided by the square root of 4. Close parentheses, enter, enter. And it's 0.022765, so 0.0228. Now realize what this is talking about. This is the chances that 4 random students have an average that's lower than 800. Let me write that up. There, this one's stating that the probability that a random group of 4 students has a sample mean less than 800 is 0.1587, or it's 0.0228. There we go. That, in other words, it is much harder for a group's average to be far from the mean, i.e. in the tails, off here in the little tails over here, than it is for an individual. Individuals can be far from the mean pretty easily, but having a group be that far from the mean, well, a group's average be that far from the mean, that's much harder to come by. All right, so that's how it affects tail probabilities. That's what we were dealing with here. So what happens in the tails? So now let's think about what happens in the center. What happens if you're near and around the mean? So let's talk about being between 900 and 1100. And again, these are the same curves that were drawn up above. So let me bring down those same labelings. 1 second. All right, so I brought down the labels. Remember that this gray curve is when n is equal to 4, and it means the standard error is 100 because it's 200 divided by the square root of 4. And this black curve here is when n is equal to 1, so that means that we are dealing with actual sigma, the standard deviation. So let's find that value first, which is this kind of checkerboarded one down here. So I want normal CDF from 900 to 1,000, 900 to 1,100, and then 1,000 is my mean and 200 is my standard error. So let me find that. So distribution, number 2, 900, 1,100, 1,000, and 200. Just plain old 200 because this is for a sample size of n equals 1. And I get 0.3829. So 0.3829. All right, now what about doing the same thing, but instead of for a sample size of 1, I want a sample size of 4. Okay, so it's going to be the same idea, except when we're in the distribution menu, for the standard error, we're going to put 200 divided by the square root of 4. And notice I didn't bother closing my parentheses there because I don't have to. I'll get 0.6827. So 0.6827. And I've already written up the steps here, 900 and 1100, 1000, and 200 over the square root of 4. You use this anytime you're talking about x bar. So you see how this bottom one is x bar, that's why we use sigma over the square root of n. So let me make a note of that. So note, when working with x bar, use standard error, not standard deviation. Use SE, better abbreviate it, SE of x bar, which is sigma over the square root of n. Sigma over the square root of n, not sigma. Right? Sigma is for when you're dealing with individuals, but when you're working with samples, the sample mean in particular, you want the standard error That's a common mistake for people to make, is they'll lose track of which chapter they're in. The n equals 1 part right here, this is actually chapter 7. We learned how to do all of that in chapter 7. The difference now in chapter 8 is we're adding in that standard error piece. Now notice what happens here. It is much easier for a random group's average to be around the mean. So easier, which means it has a higher probability, right? It's easier for a group to be near the center because people balance each other out. So you have some high scores, you have some low scores, but in general, they average each other out. So individuals are more scattered, they're more spread out. So they're more likely to be in the tails and less likely to be in the center. Groups of samples, size 4, 5, 10, it doesn't matter, are less likely to be in the tails and more likely to be in the center because your standard deviation is shrunk from 200 to the new standard error of 100. When you do that, when you take this black curve and transform it into that gray curve, you're taking all the things from the tails and shoving them towards the center. That means your spread is decreasing, and that means it's going to be easier to be in the center, harder to be in the tails. Lower probability in the tails, higher probability in the middle. All right, now hopefully that all makes sense and we are done with that example. And I'll say back here for the next example.